Antibiotic resistance is a global concern. More bacteria are becoming resistant to multiple antibiotics. Common infections such as of the gut, urinary, and respiratory tract are becoming difficult or sometimes impossible to treat. Infection with resistant bacteria may lead to prolonged recovery, increased length of hospital stay, more deaths, higher cost of treatment, and greater spread of infection and resistance. The problem is that no new class of antibiotics has been developed since the 1980s, and the health community is worried that the antibacterial drug pipeline is near empty and the achieved gains of modern medicine are at brink. For example, treatment options such as cancer chemotherapy, organ transplantation, and post-surgery outcomes would fail or have turned into high-risk procedures because of failing antibiotics. In the US, an estimated 2 million people are infected with antibiotic-resistant bacteria every year, leading to about 21,000 deaths annually. Imagine the scale of damage in India, where infections are common, waste management is poor, and antibiotics are used indiscriminately. WHO says a post-antibiotic era is a real possibility for the 21st century. And most of this is happening because of overuse and misuse of antibiotics in humans and animals. So how do bacteria become resistant to antibiotics? The resistance can be both natural and acquired. Some bacteria are naturally resistant to certain types of antibiotics, while immunity towards antibiotics can also be acquired through genetic mutation and horizontal gene transfer. Genetic mutation is a spontaneous change in the DNA of the bacteria, which helps it overcome the mitigating effect of the antibiotic. However, a common way in which bacteria acquires resistance is through the transfer of resistant genes to another one in its proximity. This is horizontal gene transfer. Use of antibiotics in humans and animals puts selective pressure, a process where non-resistant bacteria slowly die off, leaving only the resistant bacteria to flourish, identical to the theory of survival of the fittest. And there are numerous pathways for these to reach human beings. Let us look at the poultry industry to see how humans are exposed to these antibiotic-resistant bacteria. Poultry farmers feed low dosages of antibiotics to chicken throughout their growth cycle. Therefore, the gut of a chicken is not just a reservoir of antibiotic-resistant bacteria, but also of unused antibiotics. Humans are exposed to both of these through the meat that we eat and the feces and farm waste that are released into the environment. There is another category of people, like the meat handlers and cooks, who are susceptible to such exposures. This continuous interplay between antibiotics and bacteria in food, soil, water, and sewage leads to more resistance buildup, much like a chain reaction. And this chain reaction is happening every second, and more bacteria are becoming resistant. At this rate, antibiotic resistance is expected to become the biggest nightmare for healthcare providers in the 21st century.